Hello friends! This review will be dedicated to the device which has finally come to me, and I'm very glad to make this review. This is HANTEK 2D42 and this is the oscilloscope which has two channels, both are analog. Also this is digital multimeter which also can measure current, and also this device has signal generator. It comes with three probes. This is the first one, this is the second, and this is the third. So this one is most likely for the signal generator, but anyway you can use this cable for the second channel. Also we have two probes with the protectors. And for charging we have the USB charger, which is 5 volt and 2 amp device. Also, the device comes with a Type-C USB cable, which we will need for charging and PC connection. The device is fed by two lithium-ion batteries 18650. The description on them indicates 2600 mAh, but I have tested both of them with the capacity checker, and here are the results. 2460, 2381. Not bad. And this is the inscription. As for the device itself, here we have the lock. Nothing. Also nothing. This socket is designed only for the Type-C connection. No SD card. During charging process the power button is red and it turns off as soon as the device is charged. This is signal generator. This is digital multimeter. And also the connections are indicated here. And this is the scope. But first of all, let's check the menu. Here we have language English or Chinese. Sound on and off, I prefer off. Backlight 6, 7, 8, 9, 10. This is the first line from 4 lines, 1/4. Again menu 2/4. Backlight time 30 seconds. Let it be 120 seconds. Reference, save reference. Cursor, measure. So in case of cursor, enable on. We can see the yellow lines. But in case of type, not voltage, but time, we have violet to vertical cursors. 2/2. Here we have the indications of microseconds. Measurement. Enable off, enable on. Here we have the frequency and amplitude for each channel. If you don't want these parameters to be displayed, simply go to the menu, measure, and enable off. Again menu, system info, model, soft, PCB, and FPGA. Shut down in 5 minutes, calibration function, and factory settings. So that's all for the menu. In case of signal generator, you can generate the frequency or press this button to stop generating. You can change the waveform with the help of this button. Frequency can be changed with the help of these two buttons. You can increase or decrease, but in case you press the second time, you have this numeric pad, and if you want, for example, to generate 1 megahertz signal, you go to 1, enter, kilohertz, megahertz, let's say megahertz, enter, and we have 1 megahertz signal and amplitude is 2 volts. This is the first line from 2 lines. The type is the same, but we can also adjust the offset. For the sine wave, we have the maximum frequency of 25 megahertz, and in case of the square waveform, the maximum is 10 megahertz. In case of triangle, the maximum frequency is 1 megahertz. Let's check the digital multimeter. Here we have DC voltage, resistance, buzzer, DC amps, DC milliamps, DC millivolts, AC volts, AC amps, AC milliamps, and the last line 4/4 diodes and capacitors. DC voltage 3835. .383. It's excellent. 1432. 1431. Really great result. Resistance 1502. 1500. 1501. Great. Buzzer. Okay. DC amps. It's a short circuit of the old battery. Anyway, it measures. DC milliamps. So I have no such precise device in order to check this function. DC millivolts. 56 millivolts. 56 millivolts. AC volts. Let's check the mains voltage. 235, 236. AC amps. Let's check the power consumption of this lamp. This indication is correct because the lamp consumes 60 watts and the mains voltage is 236 volts. AC milliamps. We will not test this function. Diodes. This is in one direction. This another direction. And capacitors. Let's check two types of the capacitors. 204 nanofarads. And the inscription says 0.22. So it's approximately the same. 220. And here we have 204. Not bad. Another type. 12.9 microfarads. And here we have 10. Not so bad anyway. The capacitor can be checked whether it works or not. And finally, let's check the main function of this device. It's oscilloscope. We will do it with the help of another device, JINHAN JDS2023. At the present moment, the oscilloscope is connected to its own signal generator. Let's press auto. Auto setting. In order to get the frequency, we go to the menu, measure, measure on. The frequency is 43 Hz. Let's check it. 44 Hz. Now let's set the frequency to 1 kHz. 1, enter, kilohertz, enter, scope. The frequency is exactly 1 kilohertz. We press time, Very nice waveform, 50 kilohertz. Not bad. 5 0 0 0 0 0, or maybe kilohertz, but anyway it's the same. Enter. Scope. Not bad. 1 megahertz. Scope. The maximum is 10 megahertz. Nothing like square waveform. So let's define the maximum frequency at which the square waveform is okay. At 1 megahertz it's more or less okay. At 2 megahertz also we can say that it's something like square waveform. This is 3 megahertz. And in case of 4 megahertz or more, for example 5 megahertz, this is nothing like square waveform. So maximum is approximately 2 megahertz. Well, this is 2 megahertz signal. Let's compare this graph with this oscilloscope. Here it's more or less better. In this situation maybe this probe needs to be adjusted. Let's check the sine wave. The frequency is 1 megahertz. Let's check also here. It's good. 2 megahertz. Scope, okay. 5 megahertz. It's okay. 10 megahertz. It's also okay. 21 megahertz. So the signal decreases. Anyway, this is the sine wave. Also we have another types of signals. Auto. Almost the same one. We can stop. And also we can modify this picture in case of stopped signal. Very useful function. Play. So it's okay. As to the rest buttons, this is channel button, channel 1 on, coupling AC 1/2, 2/2 probe, and this is bandwidth limit. So in case of channel 2 we switch channel 2, it's off, and we can turn it on. So now green is channel 2. Now let's leave the first signal at the first channel, and the second signal will go from JINHAN device to HANTEK. Here we have the first signal triangle generated by HANTEK, and the second signal is square waveform which comes from JINHAN. So in total we have JINHAN-TEK. As to the trigger, we have source channel 1 or channel 2, and we can see how does it change everything. Rising or falling. This is double mode, auto and normal, and /22 force. Let it be off. As to this button, press F1 to recall defaults. Here we have mode YT, and the second mode is roll. So in roll mode you can observe the graph completely. In case of a long press, this is custom buttons. Custom 1, This is custom 2. Multifunction key. And data safe. As to the weight of this device, a bit more than 600 grams, including 2 batteries. Despite the fact that the device, which has 2 analog channels, cannot work in math mode, its PC software provides this function. Let's check it. The oscilloscope is connected to PC with the help of the USB cable, and we see only the channel 1 because channel 2 is turned off. Let's turn it on. The graph changes approximately every second, but it's absolutely normal because the oscilloscope sends big packages of information to the PC. Now we have 2 signals. Sinusoidal from this oscilloscope and square waveform from JINHAN JDS-2023. As to the math function, we can turn it on. Math setup. On off. This is on. And here we have the result. We can stop it. And here we can expand the time. So this sinusoidal signal plus this signal amounts to this one. And also here, in case we add this part of sinusoid to this line, we'll get the sinusoidal, approximately sinusoidal signal a bit higher. Also we can check the signal generator. As to the digital multimeter, let's check it with the help of the battery. In half a second it changes. Once again. Also here we have the graph of voltage changes. And now we have the negative voltage. Once again. And once again. In order to make changes, we can use both PC and the device itself. That's all for this review. Thanks for watching. Wish you good luck.